Hello, this is Mrs. Brown, and today we're going to be changing equations in order to make solving easier. This is going to be really important when we start doing solving systems using elimination, but it can also be helpful at other times as well. But basically, the idea is that as long as you multiply or divide every term in the equation by the same number, you don't change the value. Now remember, terms in an expression are separated by addition and subtraction signs. That's also true with equations. And it also means across the equal sign is another term. So if I look at this first equation, one term is 4x, another term is 6y, and another term is 24. So for instance, if the easiest method is to look at this and say, hey, is there a common factor in all of these numbers? Well, 2 goes into this one, 2 goes into this one, and 2 goes into this one. So one of the things that I could do is literally just divide each of these by 2. And what I get is an equivalent expression or equation. As long as I'm doing the same thing to each of those numbers, I'm going to get the same values. So 4 divided by 2 is 2, 6 divided by 2 is 3, and 24 divided by 2 is 12. So one of the ways is to find a common factor and divide out by that common factor. Okay. If you're looking at fractions, we can actually eliminate the fractions. Think about a common denominator. If I looked at the least common denominator between 5, 10, and 4, well, 5 goes into 10, so between 10 and 4 doesn't go into 10, but they both go into 20. So why don't I multiply the whole equation by 20? What ends up happening, and I'll do it out so you can kind of see what I'm doing. 5 goes into 20 4 times. 5 goes into 5 once, so this becomes 12x. 7 tenths times 20. 10 goes into 10 once, and 10 goes into 20 twice, so 7 times 2 is 14. And then if I take my 5 fourths times 20, okay, 4 goes into 20 5 times, and 4 goes into 4 once, so 5 times 5 is 25. I've just written an equivalent equation, but I have no fractions. Okay, so let's look at some other examples. We've kind of looked at this previously when we did things like you solved and you ended up with like negative y equals something. Okay, and you're not allowed to have that negative coefficient. So if I'm solving for y, I can't leave that negative. It's like negative 1. Okay, so what do? Well, I can multiply or divide through by negative 1, and it doesn't matter which one I do, but it just flips everybody's sign. So negative 1 times negative 1 is positive, so that's positive y. Positive 2 times negative 1 is negative 2x. Negative 1 times negative 4, because remember this, thinking this is like a minus 4 is a negative 4, would be plus 4. And this would be an equivalent equation that I could use when I was solving. So whatever it is that we want, we can multiply through by that number in order to change it. So when we start looking at systems, we're going to have two equations. So let's say I have 2x minus y equals 7, and I'm solving, I've got 5x minus 2y equals 12. Well, let's say I want to add these together, which we're going to do in elimination. Don't worry about it. What I need is for these to have opposite coefficients. So if this is a minus 2, I need this to be a plus 2. Well, right now it's minus. So to flip the sign, I'm going to multiply by a negative number. So I'm going to do a negative, and the coefficient's 1, and I need it to be 2. So I'd multiply that through by negative 2. By doing that, it's actually going to allow me to use elimination method in order to do this. So this is an application of what we're talking about of changing that equation. So what I would do is negative 2 times 2 is negative 4. And negative 2 times negative y, so negative times a negative is a positive, and that's 1 times 2 is 2, so it's plus 2y equals negative 14. And then if I was using elimination, I would then be able to add these two together, and y would disappear. Okay, and more on that on the next video. So again, as long as you're multiplying each term, terms are separated by addition and subtraction signs, by the same number, and you have to do it on the other side of the equation too, you're going to get an equivalent equation. Okay? I hope this helps and have a great day.